Okay, welcome to another mini lecture on astronomy OpenStax. This will be a quick video looking at Chapter 7, which is just an introductory to the solar system. We'll cover the planets and other objects in more detail, but just a quick overview as far as the planets and their distance and order from the Sun. So, overview of the planetary system, composition and structure of the planets. Here's a model of our solar system, again, heliocentric. And we could see in this model here, we have some of the objects in the Kuiper belt, so Eris and Pluto, with highly elliptical orbits. And so let's talk a little bit about a star system or our solar system. For any star system, the star is going to be the majority of the mass. So in our solar system, the sun is about 99.8 of the mass. So that leaves just about 0.2% for all the other planets and any other debris that we find in the solar system. Composition is about 98% hydrogen, helium, and 2% of these heavier elements. And just to get a sense of scale, on the image on the right here, you could see the Earth on top. But you could fit over 100 Earths side by side for the diameter of the sun. So extremely large, extremely massive. That's the majority of our solar system, and very small amount for everything else. So two major types of planets that we have. Terrestrial planets, which are small, close to the sun, made up of rocky materials. And then we have Jovian planets, which are very large, further away, made up of gas. So the first planet to the sun in our solar system is Mercury, and this is at about 0.4 AU, so about 0.4 astronomical units. And we will cover these in more detail, but just a quick overview here. It's made up of metal rocks, as all the terrestrial planets are, and the temperature is very extreme, ranging from about 800 degrees during the day and then going down to about -80 degrees Fahrenheit at night. Venus is the second planet at about 0.7 AUs from the sun. And Venus has very, very thick cloud coverings, coming from a runaway greenhouse effect. And it has these hellish conditions where it's 900 degrees Fahrenheit all the time, during the day, during the night, 24 hours a day. So extremely, extremely hot. At 1 AU from the sun is our home planet, Earth, which is just an oasis of life here. It is the only surface that we know of that has liquid water on the surface, and that's very important. We have found water other places, but here we're talking about on the actual surface. And it has a surprisingly large moon. Typically, moons are not that large compared to their planet, to their parent planet. At about 1.5 AUs is Mars. And Mars has a lot of geological features, so giant volcanoes, huge canyons, polar caps. So we do see that the polar caps thaw out, so the ice does turn into water, but most of it goes underground, and so it's not stable on the surface. And that's one of the key things with Earth, that water is on the surface. But a lot of evidence that perhaps in the past Mars did have maybe even some oceans. Slightly after Mars, we have the asteroid belt, which has a lot of debris, asteroids, rocky materials. And then it kind of leaps out a bit where we have some space for, and then we have the outer planets, which are the four giant gas planets. And this is not to scale on their distance, but just you could see Earth is here just as a reference for size. So Jupiter is at about 5 AUs from the sun, so a little bit further out. And it's not that rocky material. It's going to be mainly hydrogen, helium. It doesn't actually have a solid surface. If you stepped on it, if you went onto the planet, like stepped on it, you would sink in slowly into the core there. And you could fit about 1,300 Earths inside of it, just to kind of get a sense of scale. And in its own right, it's kind of its own little system, roughly about 70 moons or so on Jupiter. Many of those moons are just captured debris. Four the moons that we'll look at are the largest of Jupiter's moons with a lot of activity. Io has a lot of volcanic activity. Europa, we believe, has an ocean underneath. Ganymede is the largest moon in our solar system. And then Callisto, which has an old surface, and it's kind of just a large cratered ice ball. And a bit more geological features that we'll look at over the next chapters here. Saturn is up next, and Saturn is now going to be at about 10 AUs. And so very similar to Jupiter, gas giants. We recognize it with its spectacular rings. And again, close to about 70 moons as well, including Titan, which is interesting because it actually has an atmosphere. And Saturn has very low density at about 0.7. So theoretically, if there was a large enough body of water, although as massive as it is, Saturn would actually float on water. Continuing to Uranus, which is at about now at 20 AUs, so 20 astronomical units. A large gas giant, again, hydrogen, helium compounds, but not as big as Jupiter or Saturn. And it also has a lot more kind of methane, which gives it its bluish color. Close to about 30 moons or so, and it has a very extreme axis tilt, so almost at a 90 degrees, as if an object kind of knocked it on its side. And Neptune, the 8th planet, now we're at about 30 AUs, very similar to Uranus, except for the axis tilt. And then it also has many moons, probably closer to about 15 or so. And so those are the 8 planets. Again, we're at about now 30 AUs from the sun. And then we reach the Kuiper belt after that, which has a interval of ranges, but Pluto is in the Kuiper belt, which is at about 40 AUs or so. So the Kuiper belt is another kind of belt similar to the Astr belt, but it contains mainly icy comets within there. And then there is an Oort cloud, which hovers all around, kind of like a sphere around, extending out to about 50,000 AUs. So extremely large, and that also contains a lot of ice comets. Here's a close-up picture of Pluto, again made up of ice, and you could tell it's fairly large there because it has that spherical shape. This was taken by the New Horizons. And so one thing that we want to know about our solar system is how old, right? How old is our solar system? How old are objects there? And so we do this with radioactive decay. So looking at rocks or meteorites that we collect here on Earth, or we've gone to the moon, brought back samples, and we're looking at elements there such as carbon-14, and we look at half-life, so how much of those elements actually remain over time. And with that, we're able to get a pretty good estimate for the age of some of these specimens here. So radiometric dating from old moon rocks, from the oldest meteorites, suggests that the planets probably formed about 4.5 billion years ago. So that's our best estimate for the age of the solar system. Our sun is expected to live about 10 billion years. So our solar system is perhaps, or our sun is about halfway through its lifespan. But how did the solar system originate? And this is going to just be a quick overview here. We talk about solar nebulas or nebular theory. And so nebular theory describes that we have just a large cloud of gas that starts contracting and rotating. It heats up, and from that, star systems are born. These are some actual images of some planetary nurseries here. So these are stars that are being formed. And again, some coloration was added there, but you could see all the gases. And this is from the Hubble telescope, concentrated in Orion's nebula. So we'll discuss this in further detail. But a quick overview is gas tends to contract, starts compressing, it starts heating up, it starts spinning, and you start having everything rotate. And as things start colliding, objects get larger and larger, what are called planetesimals, and eventually those clear up all the debris within their orbit, and those create the planets. And so the final result is a star system or a solar system with a few planets orbiting around. Once the star actually sparks and becomes alive, its solar winds also help push out all of the leftover debris. So our solar system ends up being a very organized structure, but initially starts off very chaotic, very violent as it forms. So that's a quick overview of our solar system. We'll talk about more of these ideas in more detail as we go through all the way into chapter 14.